Couple of presentations. I think you're all in for a really good treat. The first one is one of the favorites of mine of the day, in that about a year ago we started talking with the folks at the New York Stock Exchange and NYSE Euronext about some technology that they had that they wanted to open up and share with their competitors and with the industry, and sort of leverage the same type of collaborative innovation we've been talking about all morning. And the reason that we were so interested in working with them is because the financial services industry is typified by hyper-competitiveness, right? When it's about money, people start getting really, really competitive. And NYSE is clearly a leader in their field. But they decided to take a real risk and to open up some of their key message-oriented middleware and, again, work with their competitors to take advantage of this collaborative technology. And so we have Feargal O'Sullivan here to talk about what's going on with OpenMAMA and NYSE. So welcome.
Thank you very much, Jim. Okay, thank you very much, everybody. As Jim said, my name is Feargal O'Sullivan. I'm the Global Head of Alliances for NYSE Technologies. I'm here today to talk about what we're doing with the Linux Foundation and open source software in general, clearly with a focus on the Linux platform. So just to go over briefly what I'm going to talk about so we can sort of set the stage and you can see which bits are going to be interesting for you. I'll start off with just giving you an overview of who the firm is, NYSE Technologies, what we do and what our purpose is. And then I'm going to go on just a quick primer on message-oriented middleware. Presumably this audience understands that space relatively well, but I just want to at least sort of set a baseline there for everybody. And then I'll tell you what we're doing, which is the code that we released, which we call OpenMAMA. I'm going to, probably the more interesting one on the business side is explain why we chose to do that. I think that's going to be sort of important for any of you that might have code or software or capabilities that you're thinking of releasing to the community. So that will give you some of the thought processes that went on within NYSE on this. And then we'll talk a little bit about the Linux Foundation and the license that we chose. And then finally, I'm going to wrap it up with sort of ideas of how we would like your participation in this program as well. This is definitely something we've contributed to the community, and we would like for the community to really get involved and help build it with us. Okay, so this gives you an idea of who the NYSE is. It's the photo of our office on Wall Street, 11 Wall, and that's where most people will be familiar with all the equities trading that goes on. It's approximately 30% of U.S. equities gets traded at the NYSE. As it happens, it doesn't go on in that building so much anymore. We have people on the trading floor, but they're generally typing into computers and sending their orders to a data center that we built in Mahwah, New Jersey, which is a very high-end facility with very low latency and high-performance computers. So this is a symbol that we're very proud of. And it really gives you an idea of the history there. Now, NYSE Technologies is one of the divisions within that organization, and we're basically the commercial technology arm. So we've developed a whole range of technology to run our markets, and we found that that the technology that we use is very similar to what our clients use. So if there's a way that we could take some of our own technology and sell it on to them, it will first of all help them out, and second of all, it will give us more revenue to be able to pump back in to continue to make those products better. So that's really our purpose. This is not actually our mission statement, but it's something that our CEO uses a lot, and I like it. And he basically says our goal is to reduce trading friction. So we're here about, our purpose is to find ways to reduce the cost and make it easier for any market participant to get in and start trading all the instruments. Okay? And it's capital markets focused, it's global, and it's a whole range of different types of trading instruments, not just equities. Okay, so this gives you a view of the world and some of the locations that we have data center capabilities in. The first two, Mahwah and Basildon. Mahwah is in New Jersey, and Basildon is in London, or just outside London. They're data centers that we own. They're very high-end data centers. We run our markets out of them, and we offer co-location space and so on to all of the clients to be close to the markets. And then we have a global wide area network, which goes by the acronym or the nickname SAFETY, SFTI, SAFETY, which links over 2,000 firms globally on a dedicated private extranet. And it also links into these other financial centers around the world. These are just a sampling where we also have data center space, and we offer our services out of there. So we are very much focused on all the markets globally, not just the ones that NYSE Euronext runs ourselves. Okay? And then just to wrap it up, what do we actually offer people? Well, we offer infrastructure as a service capabilities, which could be sort of straightforward co-location, all the way up to a cloud environment that we built and launched last year, which is a sort of virtualization environment, compute on demand. Okay? It also has physical machines, because within financial services, people are very concerned about latency, and they often want to get right down as close as they can to the kernel. And then we have a sort of a range of platform services. So for financial services industry, that generally means market data. How do you access subscribing to quotes and trades and updates? And then other things like risk management, trade reporting, historical market data, fix order routing. When FIX is a standard as well, that's quite big in the industry, where we take orders and we're able to route them from one participant, for example, a buy side, maybe a fund. They can route their orders to the particular broker or to the market that they want to get to, and they only have to make one connection and do that. So these are sort of platform as a service capabilities. They're not products. It's not like you're sitting looking at a screen. It's more about saying, let me connect my application to this service. Okay? The top 4 circles are just showing the types of segments, we call them, that we target. Systematic traders are doing computerized trading, institutional investors, and so on. We also have actually a quite strong business supporting other exchanges, and there are a number of exchanges around the world that use our trading engines only to run their markets. So we actually have a pretty broad portfolio of services. Okay, so that's a little bit about us. Now, let's talk about middleware. So the message-oriented middleware, or MOM, and you're going to see a few Oedipal-type references in here, but MOM is a way for applications to communicate amongst themselves, and really the big benefit is that they're completely decoupled, so they don't necessarily have to know about anybody else being out there. If I have a piece of information and I think it might be interesting, I send it to my middleware, and my middleware makes sure it gets to anybody who actually cares about getting it. Okay? So that's sort of a straightforward view of it. Really, I don't need to know who they are. There are 2 primary paradigms about how this gets done today. You're probably familiar with these. Publish and subscribe is one of the very common ones, and then queuing is the other one. So with publish and subscribe, it's really a case of I have a piece of information and I broadcast it out, and if you care, you subscribe. It's more like the sort of the television model. I'm broadcasting, and if you want to tune in, you'll get it, and if you don't, you won't. And then the queuing one is, I'm going to take all the messages I have, I'm going to drop them into a nice big bucket, and then you can come along and read out of that bucket whenever you want. Okay, and those are 2 very common forms. Typically, you use some sort of a naming scheme to put on your messages, so when you send out some information, you're able to say what it is in advance. Now, in the market data world, which is where we primarily use middleware, this would commonly be the symbol that you're trading. So if you were trading, for example, IBM, which is the common ticker symbol that everybody talks about, you'll name it quote.ibm or something along those lines. And now when I publish that out, anybody who's actually interested, they just tell their middleware, I'd like to subscribe to any message that comes by with a subject name quote.ibm. Okay, so that's pretty common. Queues would also have a name. You would say, I want to go to the quote queue, or the equities quote queue, or the foreign exchange quote queue, or the commodities queue. And then you could just start reading from those queues. Now, this is a key point about why we're here. There are a range of middleware systems out there, and they are pretty much mostly proprietary. So typically, the API that these middleware systems use is custom to the platform it was developed for, and you don't get to really swap around easily, because if you're using one middleware platform, you've developed to their API, and if you choose to move to another one, you now have to switch and write to their API. Okay? So let's take a look at what this might be like. So if you see here, I've obviously made this as absolutely simple as I possibly could. But if you were, for example, to have the market, in this case the New York Stock Exchange, sending a quote out, typically what a firm might do with that quote is they would have a process called a feed handler. Okay, and it would listen to that packet. The quotes come down on a UDP multicast basis, and every exchange typically has a proprietary format for how the data is published and how it looks. So you see a packet, you need to have a feed handler that will take that information and, for example, normalize it, turn it into something that your downstream application can understand. You don't want to have to write your application to understand the difference between the New York Stock Exchange and the NASDAQ Exchange and ARCA and the CME and the London Stock Exchange and all the others. It becomes very messy if every single application needs to know about every one of those markets. So you'll typically write a feed handler that will normalize it. It would then send that update as a message on a middleware system to a caching system. And the cache is a last known value cache. So it will take the update, and it will say there might be 100 fields in a record, and only 10 changed. It will take the 10 that are new, it will insert them into the cache, and then the cache will publish the update down to an algorithm. The algorithm will then say, is it a good time to buy or sell this particular instrument? If it decides it is, it will create an order, and it will send it to a gateway. And there's a couple of other steps that could happen in the middle here, but just trying to make it very simple. And the gateway will then format that trade into a type of message that the particular exchange you're sending to understands, and it will forward it to that. Okay, so this would be a very sort of straightforward approach. Now you could just go ahead and write the feed handler to make a socket connection to the cache, and the cache to the algo, and the algo to the gateway, and you'd be good to go. But it starts to get more complicated because nobody ever goes to just one market. So often people will get different types of feeds in. So here I'm showing, just one market. Typically they would have 10 or 20 or 30 different markets. I've also got a consolidated market data feed in here, which is where you care to see information maybe from around the world, where you want a more breadth without having to take in all those raw feeds. So you might take a consolidated feed, in this case super feed, and you might be creating your own prices. For example, if you're trading FX, a bank will always put its own spread on that and publish out that rate to its users. So it's not just taking what was the last trade, but it's taking that and saying, but if we're going to trade this, we want X amount of margin on the trade. Okay? So now I've got 3 systems, so now I would have to do socket connections from all 3 to the cache. So adding any one of those means I'm touching that cache, and every time I touch a piece of software, I'm risking breaking it. Now I'm probably doing more algorithms, so I've got 3 of those up there, and now I'm actually trading on multiple different markets as well, so I have 3 more of those. But I'm still not done, because I might want to add desktop traders who want to look at the prices coming down. The problem with the desktop traders is that the market data rates are way too high for any typical laptop or desktop machine to keep up with those rates. So for example, the options price reporting feed peaks at over 6 million updates per second coming off the feed. Okay, so this is very high volume. You basically, to handle all North American equities and options, you need at least a 10 gigabit pipe just on the backbone where all those feed handlers are. So it's very, very high volume that you need. So you're not going to get a desktop to subscribe to that. So you might decide to put in something called a conflation cache, which will actually listen to all the changes, but it will only release an update on a set time period. So every interval, maybe every half a second, I'll give you a new tick. And at that instant, it is the correct price. But I didn't do it might have traded 100 times in between my sending you each one of those updates. But given that it takes you quite a while to click and type in your order, That's, you're generally not doing low latency trading if you're involved at all. So now you need another process in there. And then, of course, another very common thing people will do is they want to capture all these ticks. And then this is now mission critical trading, billions of dollars a day, if not trillions. So you better be monitoring it all. Now, if you look at the view of what that looks like if you did it point to point, you're making lots and lots of arrows between lots of systems. And I haven't even shown fault tolerance. And I haven't shown when you actually start to add the correct number of processes that are doing this. So trying to make all socket connections between all of these things will completely kill your management capability. It'll kill your performance. It'll require you to send the updates 3 times. Typically, we use multicast in between. So, if you're point to point, you're going to kill that. But you have to send it 100 times if there's 100 people looking. Okay, so there really are. You can do this without middleware. It looks like this, and it looks a lot worse when you go into production. Okay? All right, just because I know not everybody here is in financial services, I just want to put up a few other use cases for where people use middleware. Maybe some of you are familiar with these already. In the high-performance computing space where you have, 2, 3, 10,000 nodes all doing little jobs, processing different requests, it's quite common to use a middleware platform to distribute out the data that those jobs need and maybe even the instructions to the machines to say, hey, you start working on this job and you work on this job. And it can be done quite easily with a middleware because you sort of put topics on all the messages and then you have certain nodes listening for certain topics and other nodes listening for other topics. And it means that when you go to scale, you can throw on another 1,000 servers and you just start telling them you listen out for a different range of topics. So you're really splitting up your topic space rather than your socket space where you're making connections. So that's quite a common use case. Service-oriented architecture, that was, I suppose, about 5 years ago. That was the big buzzword. Everybody was really into SOA. But the basic idea of writing your code as modules, and you just add in a new module. And if you do this type of model, you really need a middleware underneath it so that, again, you're not impacting every other component as you add a new one. Scalable web database queries. So middleware is used very heavily by the likes of eBay and Google and other big, web environments where they want to try to send, you send your request. They might broadcast it out, and all the databases have queues of queries, and one says, "Great, that's my topic space. I'll grab it and I'll run that response." And so it gives you a very much easier way to scale out your environment there. And then the last one that's quite common as well as in transactional applications. So going to a cash machine, taking money out of a cash machine, when you get the $20 bill, or maybe more if you're lucky, they want to make sure that message from wherever you are in the world makes it back to the correct database and updates the database and updates the backup database and then commits both and then comes back and confirms before giving you the money. Okay, so they'll typically use a middleware platform. They have a transaction process manager then to ensure that it gets done. And if it fails for some reason, it might have updated one, but it failed the backup, you roll it back. And again, this can be more easily handled if you have a middleware in between your applications. Okay, so that's a basic idea. That's enough of setting the stage. So what is OpenMAMA then, and what are we doing? Well, MAMA stands for the Middleware Agnostic Messaging API, and I mentioned that there's a lot of, mother-type references here. But it is an API that we developed about 8 years ago to try to shield us from the fact that there were lots of different choices of middleware that all of our clients were using. So every time we went to a new client and we were trying to sell them a market data ticker plant with feed handlers and all of these capabilities, they would come back and say, well, we use Tibco Rendezvous, and oh, we have to support that. And somebody else uses LBM, and somebody else wants Elvin, and somebody else wanted some other middleware. And we couldn't every time take our feed handlers, recompile, every time we had a change, recompile the feed handler and link it to 3, 4, 5 different middlewares and then go through the whole QA cycle every time. So we chose to write a wrapper layer that we could protect ourselves with. Okay? So we support a variety of messaging platforms already. I'll talk a little bit about which ones we've got covered in a minute. We make it very consistent. So when you write to MAMA, you don't have to know about which middleware you're using. And we made it very, very high performance. This is an absolute critical feature of this API. If it was going to slow people down, we would never get anybody to use it. Because people in our industry measure things now. They are literally measuring the performance of applications in nanoseconds now. And that's, steps along the way. There might be 10 steps, but it's reasonable to think that there are people trading today in under 10 microseconds from when a quote comes in until when they make a decision and send their trade out. And that's with risk checks and everything. So people are doing absolutely ridiculous things to try to get the performance up, and they will not accept an API if it's going to slow them down. So we're pretty confident that our API can perform in under a microsecond. I think sort of the benchmarking we do is about 1 million updates per second of 200-byte messages, and we process that in under a microsecond. You're getting a wrapper that wouldn't be there, that microsecond, if you use the native API. But the fact that you can now pick and choose when a faster middleware comes out, just plonk it right in, might give you the reason why you want to use it. Now, it's OpenMAMA now because we open sourced it, and it is now contributed to the community, and any of you can go to openmama.org and download it and use it in your own applications. And that's really why we're here, is to try to encourage you to do that, and hopefully to get you to contribute back in and continue to make this even better. We're hosting with the Linux Foundation, which is a very important feature I'll talk about in a minute, and we have a very complementary group of industry stakeholders that are actually behind this and helping to drive the standard and bringing it forward. So we really have a great amount of momentum on this, and we want to continue that momentum and make it work. Okay, so what does this really mean? Well, if you sort of, I'll flatten out the previous diagram, which was logical anyhow. Typically, you would have one middleware bus. So for example, in an environment where you might have a range of feed handlers and some caching and some algos and things running, and maybe you're using one of the platforms that's quite common. It's called LBM, Latency Busting Messaging was the long name of that. But that's by a company called Informatica. And if you use their middleware and write to their API, you've got your system working. But then you decide you'd like to change, for example, maybe to Tibco Rendezvous. Not trying to pick favorites, but just it's a very common one that's used out there. So you decide you want to change. You now need to go into all of those applications, and you need to literally rewrite them to the RV API, and then recode, recompile, and then retest and everything else. That's a lot of work. That's a lot of risk. Most people don't like doing it, so they tend not to unless they really have to. If you used OpenMAMA instead, you write all your apps once to OpenMAMA, and now you can swap out the middleware without changing anything above. So in this case, I got a little plug-in for our own middleware. It's called Data Fabric 6, and it has an RDMA and a verb-level implementation. So that now I was able to swap without having to change any of my upstream applications. Okay, so that's a considerable thing. But it's even better because I could actually use multiple types of middleware underneath the application without having to rewrite any of my applications. Okay, so these are the 4 that are supported today. We have our own data fabric. Informatica LBM is covered. Tibco Rendezvous is covered. And there's an open source implementation of the Elven middleware, which is called Avis. Okay, those 4 are officially supported today. And I now could maybe be sending quotes out of one of those and trades out of a different one. And I haven't had to change my application. I just changed the configuration of saying which topics go on which session. Okay, so that's really what's unique about that. What's better is that we've also opened it up to the industry and have got a number of vendors actually writing bridges to their middlewares. And we're expecting to get a lot more. So a client could just, for example, write to IBM WebSphere MQ, or MQ Series as it used to be called, and do that today. We're hopeful that we'll get maybe IBM to get on board and support that going forward. Solid Systems, same thing. That's a hardware accelerated middleware sort of appliance. AMQP, something that Red Hat are working on, and we're hoping to get them to support this as well. So it's now wide open that the vendors can do it or clients could do it for themselves. If they really love a middleware, just write a bridge. You still don't have to change your applications, and you get advantage of the other solutions. Okay? And everything is now pluggable and interchangeable just with a configuration change. So if I get into a little bit more on the business side. why did we open MAMA? OpenMAMA, I suppose. Well, first of all, we had a relatively small team of developers that were working on this API. They were building it for our specific needs from our clients. And our clients would often say, hey, we'd really like you to support another type of middleware. And we'd say, OK, well, are you going to pay us to do the work? And they would say, no, we're not. And then we'd say, well, then we can't do it. We're busy doing other stuff. So it really was a case of saying that if we actually contribute this to our clients, they could go and just write that bridge themselves, and they wouldn't have to bother us. They'd be happier, and they would continue to use our other services. And you saw my slide at the beginning where I talked about platform as a service. So they could now actually leverage all of those capabilities without having to change out on the APIs. So we feel that more contributors will lead to more features, fewer bugs, and all in less time. So that was probably that's the simple reason why we would want to do it. Okay. We also wanted to make it easier to access all of our systems and our software. We have a wide range of capabilities, but more importantly, we have our community now. We have our data centers and our global network with over 2,000 financial services firms connected, and we want to have a way for all of those clients to communicate amongst themselves and with us using a set of open standards, so that now they're not feeling like we're locking them in the way many of the other vendors do. And this was really a key point, is that if we're going to get a community to start delivering and bringing in applications together, then we need to make it in such a way they don't feel like we've locked them into that. Okay, so that was a big thing. My role now this year as sort of global head of alliances is to really build out that community. And this is a real key part of the strategy, to say to vendors, come on in. We'll give you literally a set of standards that are completely open to the industry. Develop your applications to those, and now you can plug into our 2,000 clients without having to change a thing. And in many cases, as you'll see when I go a little further, that will lead to competition. And then the last one was just thought leadership, which is, we're not known as a technology company. We're that old building that you saw with the columns and everything else. It's not seen as, hey, those, everybody, I was just talking to some of the people earlier, and they're going on about trading places. I don't know if you all remember that movie where they were throwing paper around, and one of the Linux Foundation members was up because we're hosting the user conference on the Exchange floor at the end of this month, and she was saying, "Where's all the paper?" And everybody was just laughing at her because they haven't used paper in quite some time. Whoops. Somebody's really annoyed about that, huh? But yeah, so the technology is really important to us, but we need to we want to show people that actually, we get it, we understand the technology, we want to drive it, we use it very, very heavily ourselves. I mean, all of our systems are Linux-based, and we write very high-performance software, and we tweak and optimize like crazy. And we want to show the rest of the industry, like, we are considered, sort of the marquee of almost capitalism itself, really. So we want to show the rest of the financial services industry to stop playing around with proprietary stuff where they're locked in and they're not making any new features or capabilities because they're stuck with whatever the vendor A gave them or vendor B gave them. And let's get beyond that. Let's make the plumbing open, and then you can add actual features that make new capabilities and new ways of trading that's going to add real value, instead of just saying, well, I wrote a better new way of doing the same old thing that we've done before. Okay, so that was sort of important. Now, there was a lot of risks in doing this. First of all, we hadn't written MAMA originally to be open source. And secondly, we had pretty much coupled it in with all of our stuff. So we needed to go through before we could open this up, and we really needed to look at the code itself. And we probably spent about 6 months cleaning it up, commenting it, making it something that you could give to somebody without any help and say, download and start using this now. And I would certainly, suggest that if you want to go to openmama.org and try that and tell me whether I'm right or not, and if not, let me know, and I'll beat up our developers a little more. But it was important, right, that you could use it. So we needed to be concerned about that. The business risks were higher. We're losing revenue by opening this. It's not free. We have to pay people to get the code ready and to release it. And we have a project manager running the overall project, and we have a maintainer who's officially maintaining the code. So even though it's completely open source, you need structure to make it work. And we're investing in that, but we're also losing revenue by not being able to sell this API. We used to sell it to clients; it was a value add. So that was certainly a risk. We were worried about overestimating or underestimating the actual amount of interest, because should we put 2 people on it or 10 people on it or nobody on it? So that was a concern that we had to think through carefully. We're losing control over the platform itself. It's now open to the community and all of you to contribute and decide which way you want it to go. And you could decide you don't want it to go anywhere near low latency, and that might be an issue for us. We'll have to wait and see. And then we didn't want to cause confusion in the marketplace either. Clients thinking, hey, what are you doing? Who owns the API? Who do I call? How do I get support? Within financial services, they're not really allowed to release applications that are built on code that they do not have a maintenance contract on. So it was very important that we were able to say, well, we will offer a maintenance service for the open source code. And so that was pretty important as well. And then, of course, there were legal risks. I think the biggest one is there anything in any of our current contracts that would prevent us from actually releasing this code as open source? So we had to scour through all of the contracts and make sure that we hadn't said, oh, here you go, you get a license to the source code and so on. So that was important. Our existing commercial relationships with other vendors, if we open up this API and we currently have a relationship with Tibco and Informatica and other vendors, how will that play out? We had to make sure that the contracts would allow it. And then we, of course, had to make sure that we could come up with a good trademark and copyright on the name, and it wasn't at risk on that. So when we're thinking about all of this internally, the vast majority of people were very conservative about it. I think this debate went on for about 3, maybe 4 years. I've been there 3 years. I certainly came in suggesting we do it, and it took 2 more years to actually get it done. So it was a big move and shouldn't be taken lightly, and I don't think we did take it lightly. The sort of conservative idea was, well, what if we just release the headers, or what if we just release the bridge APIs so you could write your own? But I think ultimately most people felt, even within the firm, that if we did it like that, everybody would see it as a sort of a half-hearted attempt at doing open source and not really believing in it. And therefore, most of our clients wouldn't be confident enough to say, I'm taking that API and I'm going to use it for myself. Okay? So what we actually ended up doing was opening up not only the OpenMAMA, but we actually took the data model for our market data as well. And that's a whole other layer, because market data is a real beast. I don't know if any of you are in the business, but I'm getting a headache just thinking about it. It is very, very messy. There were 18,000 notifications from the exchanges around the world that we had to process last year about possible changes. Something like 250 times we had to change source code. So many of those 18,000 were just, hey, it's, by the way, there's a new instrument on there, but you don't have to change anything, But then there'll be other cases, well, the configurations change. We've split the multicast groups from 1 into 2, or into, an Opera is, I think, 48 different multicast groups now, because it's just so huge in the volume that you have to split it up. And so that requires us testing those changes, making sure we can do that, right? And then about 240 or 250 times, we actually had to rewrite feed handlers. And about 20 or 30 times, we had to write brand new feed handlers. So you're talking about 2 or 3 changes a week to code is in the market data space today. And that data model and what you do with a code and how you process it is so important to the business that we felt like if we open that up, it will really change the game. Right? It means that any feed from any vendor could talk to, any application could talk to any vendor, not just their middleware, but their content as well. We also had the risk of impacting our business lines. Some were good, like our community. That's great because everybody, will be more likely to come to our community now. But our software business may be less likely because now you can get a different feed handler from a different vendor, and it will look mostly like what ours does. So if it performs better, then people might choose it. So that was a bit of a risk. As you can see, we required sponsorship at the highest level, which we did get. We needed to get to the CEO and make sure they were happy with it. Okay, so why do we pick the Linux Foundation? This should be obvious to everybody here because you've all selected it too, but there's no harm in reiterating the points. Neutral reputation, that encourages collaboration. People feel like this is hosted by the Linux Foundation. It is real. Nobody is taking some proprietary stake in it or some advantage out of it. If everybody is in there, I contribute. It's a whole community committing resources each. It was great for increasing the awareness of it. Thank you, Jim, for the opportunity to speak here. Because we really do want to see everybody take this on and use it very heavily. So getting awareness and bringing in a lot of the other already the members of the Linux Foundation who joined our committee. We've got the technical infrastructure for hosting all of this and making it available. Great legal support. That was really, really key, being able to make sure that we picked our license agreements right and went over all of our own contracts. The marketing platform, and then just the ongoing, guidance that we get. Are you delivering, this issue came up, what should we do? Well, we can just ask the Linux Foundation. They've seen it all before, so they're able to help us walk through that. So really, we feel like we came to market with a very professional, open source environment. And we did it because we went to the experts who've done it before, and we just took their advice, so it made it a little easier. And then we also got great participants, which I'll talk about in a minute as well. So why did we pick LGPL? That's the choice that we made. So first of all, it's well known, understood, and credible, especially with commercial businesses. But it's respected in the community and gave us sort of a neutral place to ensure somebody who could own it, or a neutral place to be able to define the trademark and copyright. But the most important one was that it really lends itself to a commercial business model, which is what we're in, right? So we all have to get paid, and to get paid, we have to sell something. So we have, with this agreement, we're able to link the OpenMAMA into our applications, and other vendors are able to link it in and distribute it without breaking the license agreement. And we feel that it encourages the members to contribute without obligating them to do so. Where somebody says, well, I can't use that because my product has feature X that's so much better than everybody else's, we can say, great, go and write that piece, add it into the OpenMAMA code. We'll ship it out with the with the libraries, and now your product still works. You don't have to feel like you still have whatever that feature is. You're still the only middleware that has that feature. And then again, it minimized the impact on us. So we found it quite easy to, when we ran through all of our various contracts, we didn't really have to make too many changes at all. Okay, so how are we structured? Well, straightforward. We have the Linux Foundation hosting it. We have a steering committee, which is a member. It's about 10 firms are now members of that. And the steering committee meet monthly, and they sort of analyze the product, where it is, what features they'd like to see, what priorities to make, and talk about which other participants we'd like to join that committee, and so on. Okay, so that's really what the steering group or steering committee does. And then they might break out technical groups that would go off and say, oh, we're going to add feature X, we're going to add feature Y. And then there would be an actual group of developers or engineers who would meet on that particular topic, write the code, contribute it back, and then the steering group goes, hey, that's great, thank you very much. So that's really a pretty straightforward model. When we launched, we got some good press. I particularly like the Wired one. This was launched on October 31st, and it was in the middle of the Occupy Wall Street movement. So we won't share the wealth, but we will share the code, which was nice. But we had, great downloads, and it's been going very strong since. So we expect, we really expect to get a lot more as this continues forward. These are all the firms that are on the steering committee today. What's really interesting about this is the mixture. So what you'll see is actual end users like JP Morgan Chase and Bank of America Merrill Lynch are on the steering committee. They're end users of our products. They both have many different types of middleware wrappers that they've written themselves over the years. And they have instead chosen now to standardize on OpenMAMA. Now, they're big organizations. It might not be everywhere. But they are certainly making the effort to drive this into their own organizations to say, we'll develop on this standard, and then we can use whatever middleware we choose underneath. We also have competitors, okay? Exegy and Interactive Data and Fixnetics and DOT all make market data feeds. They compete directly with NYSE technologies. They are on the steering committee, and they are helping us define what new features we need to add to make the product better. In fact, we have way more install base for the MAMA API than they have necessarily for their APIs. So we feel like this is a real big give. We're literally allowing them to walk into every one of our clients and say, you know those feed handlers that NYSE makes? Yeah, I got a better one of those. Right? Now, that might be not true, and that's our goal, is to tell them that it isn't the case. But we've opened it up. It's simple now for people to swap that out. And this is the point about going open. When we did it, we knew we had to go all out. If we didn't get market data vendors on, it wouldn't be credible. And then we just have a few sort of tool companies that TS Associates do latency monitoring and stuff. So these are the people that are on. There are a number of big names, some of whom are on the board behind me, that are hopefully going to be joining in the not too distant future. So we really see this as going very, very well. And the amount, while this is very much focused on financial services, and that's a key point I want to drive home, that's just the heritage. But where we're going, or where we would like to see this go, is to be cross-industry. It's just a middleware API, right? It's a middleware agnostic messaging API. It takes content of whatever kind and sends it from one place to the other. Or at least in this case, it wraps it and passes it to your middleware, who does the job of sending it. So it's not something that you have to think about as only financial services. There are a number of different industry vendors that the Linux Foundation has already introduced us to that are very interested in participating and contributing and using this code. And we think we have a good chance of really driving this out to everybody else. And that's why we're here really to ask you is if you would be willing to participate and help us with this. We could make this be a default part of the distro and make everybody use it. And I think it will. It just takes one more sort of block away from you when you're trying to design your applications and choose the best approach. So, just to be clear, anyone can participate. You don't have to be a corporation. You just be any developer. We would like you to use OpenMAMA in your applications. And when you're talking to, if you are using a middleware vendor, when you're talking to them, suggest that they start supporting this as a standard. Okay, that would be very nice too. All industries are encouraged, and we're really continuously looking for people to join the steering group and the technical groups as well to try to help us guide and drive this forward to meet your needs. Okay, and we're just, we're really just here to facilitate. That's what our job is. So it really is up to you. If you get involved, this will be a great success, and if not, it'll probably just be okay. So just to summarize. We took OpenMAMA because we wanted to open up the space in the capital markets to competition. We think OpenMAMA should be a great use for you to help simplify the development of your applications where you're using middleware. We hosted here with the Linux Foundation, LGPL 2.1, and we absolutely would like to see you all participate, so please do. So we have about maybe 2 minutes. I don't know if there are any questions. I'm happy to take them. I know there's a couple of mics floating around, but if there are any, please feel free. Otherwise, I will be here as well later. Anybody have any questions? And I will add that tomorrow, Mike Schoenberg, who's the maintainer of the code, is going to be doing a breakout session in one of the rooms from 9 to 11. I'll do a little bit with him, but he's going to give much more detail on middleware, and in particular MAMA, and he's even going to do some code samples as well. So if you really want to get techie, by all means, come by. Yeah, sorry. Yeah.
You'll have to repeat it.
Okay.
What's the most difficult thing you had to convince your CEO of to convince him to do MAMA?
Okay. Do you want to ask it again? No. I'll do it. So
how difficult was it to convince the CEO?
The CEO. How difficult was it to convince the CEO? The most difficult thing was what's it going to do to the bottom line? So what they care about is, are we going to lose a lot of revenue by doing this? And I think, we made the case that we're going to, offer a maintenance service. So most of our clients will continue to pay us the maintenance fees. We have pretty established footprint already, so we expect that particular revenue stream not to be affected too much. And then hopefully by the fact that we've opened up our middleware, which we think is very, very high performing, might even get a further foothold. So anything we would lose by not being able to sell MAMA, we would make up by being able to sell our data fabric middleware. So that was really what, in the end, he was like, okay, fair enough, it looks like it's a nice balance. Yep. Yeah, sorry, one question over here, yeah.
So how does your competitors see this platform, and what type of collaborations you have with them, like BATS, Turquoise?
Right. Okay. So BATS and Turquoise and other exchanges have not really taken part in this yet. It's a slightly different. They are competitors of NYSE Euronext. Not strictly competitors of NYSE Technologies. They're certainly not in the middleware play. They don't really have a space there. That being said, we are working to standardize our market data feeds. So the way data comes out of the New York Stock Exchange today is using a platform called UTP. And basically they come down as UDP packets on the wire. It's a binary format. And you have to listen to these packets, and you have to know what they look like, and you have to process them and unpack them. We're actually working with the exchange to see, can we get them to upgrade and make OpenMAMA standard. And in that scenario, we would ideally go to the other exchanges and say, why don't you all do the same? And this problem of 18,000 notifications and 250 new feed handlers a year could possibly go away. I don't think it will, because everybody is always into competition and coming up with better ways of doing things, but it could certainly help. So that's our model there. I think that might be it for time.
Yeah, well, thank you very much.
Thank you.
Really good talk.
Thank you very much. Yeah.
And also, I also want to thank you for hosting our End User Summit at the end of the month at the New York Stock Exchange. Yeah. For any of you who wish to attend, this is an invitation-only event for large consumers, people who are transacting gajillions of dollars every day or doing, cutting-edge, broad-scale use of Linux. We have this incredible event where all the greatest technology minds come together and discuss, file system, I/O, technical challenges. So if you'd like an invitation to that event, feel free to get onto our website and request an invite. And thank you for hosting.
Thank you.
So.